Hi guys, so now we're going to discuss about arenes. This covers the introduction to arenes or aryl compounds for A levels chemistry. So if you see here, there is arene. Arene is actually different than benzene ring, although those two are really connected because arene here is actually a hydrocarbon that contain benzene rings. If you want to say any compounds with benzene rings, we call that as aryl compounds. That's why we have aromatic compounds, halogenoarenes, it's all aryl compounds, and sometimes they also refer to arenes. So yeah, as you know, if I say like benzene ring, you will automatically think of this structure, which we call Kekule structure here. But this is actually wrong, guys. This is actually wrong. Why? Because if you see here, there are 3 double bonds and 3 single bonds, which means that you know that the bond length between double and single bonds are different, and also you know that benzene ring should have a perfect hexagonal shape, but due to this bond difference in bond lengths, it makes this structure not a perfect hexagonal shape. That's the first reason why this structure is not arene. Second is because the chemistry itself, like the reactions it undergoes, this structure is definitely different than alkene. Because if you say that this structure actually has 3 double bonds, then it will undergo addition reaction like alkene. But in reality, it doesn't do so. So if you see here, it distorts the perfect hexagonal shape. Actual bonds are actually between single bond and double bond, and all are the same. So there are no single or double bonds separated distinctively, and it also won't decolorize bromine water easily, called the substitution. So if you remember, for the alkene reaction, they undergo an electrophilic addition with bromine to decolorize it. That's why if we want to test for double bond double bond presence, then we will test with bromine water. But in arene or benzene, they actually undergo an electrophilic substitution mechanism. It's not electrophilic addition, which makes it different than alkene. That's why definitely there are no distinctive or separated double bonds like here in this structure. So the real structure is actually this structure. This structure is the real structure of benzene ring. Here, as you can see there, that's the real structure. It doesn't have any distinctive 3 double bonds and 3 single bonds. It's like a ring because each carbon actually have a pi bonds, and the pi bonds, they overlap each other in these 6 carbons and form a delocalized system, or sometimes we refer to a pi delocalized system or pi bonding system. And all is sp2, as you can see here. And yeah, this is basically the introduction, and you can see some of the compounds benzene can make, some of the aryl compounds here. And yeah, please remember this, guys. Thank you.